All right, so ECAN, or economic attention allocation, is the method of spreading, about allocating both memory and processing resources inside OpenCog. So we have in the current implementation, there's two numbers associated with each atom in OpenCog. One is short-term importance, one is long-term importance, and
we have three numbers. VLTI.
Oh yeah, that's a bit. Yeah, but I guess a bit could be called a number. Yeah. Or it was supposed to be a
VLTI
bit.
is. I thought it was an integer.
Maybe.
It's the incremented and decremented.
Perhaps at some point it was a bit, but maybe it was made an integer for implementation simplicity. So the idea is that the short-term importance, vaguely, it's an estimate of the probability that the atom is going to be useful in the near future. So this number is generally used by cognitive processes to grab an atom to do something with. Because there may be a lot of atoms in the atom space, a lot of nodes and links in the graph. And so if you're doing reasoning or figuring out what to say, you want to pick some of them preferentially over others. So it's vaguely like activation in a neural network. Long-term importance is roughly the probability that the atom is going to be useful at some point in the not too distant future. So that's basically used to determine whether to keep the atom in RAM or not. And there's a forgetting agent that if RAM is full, periodically goes through and kicks low long-term importance atoms out of RAM. Now the VLTI was basically intended as a flag, but it could be more complex than that. So in the simplest form, the VLTI just told you, when you forget an atom, do you bother to save it to disk, or do you just vaporize it? Now, of course, there could be multiple levels in theory. You could have many different levels of memory. You could send some to tape drive and some to disk or something. So there could be some argument for having different levels of VLTI. Right now, that's not used at all, as far as I know anyway. So, but when you're running a persistent mind, it's doing a lot of learning and reasoning and discovering things. I think it does make sense, because something that has been figured out or learned or heard, like things that people said to the AI, you do want to remember and save on disk, but speculative intermediate results that it comes up with in the middle of some thought process don't necessarily need to be persisted. I mean, you might want to, if you're wanting to save all results of everything the system did to study later, but potentially it could also slow you down to keep coming up with intermediate things, deleting them and saving them to disk, and you might not want to. So
you can always explicitly save things if you want to.
Yeah, sure. This is more whether something gets automatically saved when the forgetting agent kicks it out of memory, right? And so the idea of having these just three numbers, it's sort of a simplification, because conceptually, you could ask, what's the probability that this atom will be useful for this purpose on this time scale, right? And sometimes you may want to do that, but that becomes very expensive to calculate and a lot of information to remember. So that having two numbers is a simplification, and that's not quite unique to OpenCog. I've seen like Sam Adams' cognitive architecture, Joshua Blue has two numbers like that, and some others probably do also.
And screensaver length.
So let's see. So it's a sort of neural net-like portion of OpenCog, although not like a deep neural net that you're training based on specific training data. It's more like a asymmetric Hopfield network or something, where you just have a bunch of nodes and links all connected to each other, and they're just spreading stuff around. And there's a number of processes. I just wrote this list this morning, so I might have left something out. But the one basic process is importance spreads. So if a node or link has some importance and it's linked to other things, it spreads importance along its links to its neighbors, which is much like spreading activation in a neural net, although I'll talk in a moment about the equations it uses. Then there's something called importance updating, which, for example, decays importance at a certain rate. And the decay rate can be different depending on various factors. So again, that's very much like a plain vanilla neural network, where activation can decay and can spread. There's a forgetting process, which is a little different. Things with low long-term importance can get forgotten. And the spreading and updating right now happens separately for short-term and long-term importance. So they're parallel processes with very, very similar equations. Now, there's what you call stimulation, which means someone says, hey, this atom was important. And so that happens outside of ECAN. So as one example, if PLN inference draws a conclusion, and that conclusion is evaluated as interesting, it's confident, it's surprising, it's something, then PLN can stimulate that atom, meaning it boosts it with some importance. And in language processing or vision, we give some stimulus to new perceptions that come in. So the system will pay some attention to the new perceptions. Now there's a bunch of parameters in ECAN, and Ms. Ghana and I have paid some attention to updating these parameters sort of adaptively, so the whole attention allocation network is working well. So we'll talk about that in a bit. Then we can form what are called HebbianLinks, and that the idea there is if two atoms are often important at the same time, you may build a link between them and update its weight to acknowledge that. And that's much like just classic Hebbian learning in neural networks. So these are all interlinked but separate processes, and they used to be done until maybe 6 months ago. They used to be done within something called the scheduler that was in the COG server in OpenCog. So the scheduler had the notion of a cycle, and it just looped through that cycle over and over again. And each time it went through the cycle, it did each of these things. And we
cooperative multi-threading.
Yeah, we'd gotten tired of that architecture a long time ago, but just didn't get around to.
It's still there. It's still.
The scheduler
It's still there.
Scheduler exists, but now that ECAN doesn't use it, I'm not sure anything uses it. So it is still there, but maybe we can get rid of it. Or
On some rainy day, I'll get rid of it.
yeah. So one of the things Ms. Ghana did with some help from Roman is essentially each one of these runs in its own thread now, so that they're just running parallel to each other. And then much as we discussed in a meeting previously, perhaps in the, can't remember if that was a Cogathon, that was some other meeting with Cassio in the conference room. We discussed doing these things in multiple threads, and then if we need to sort of balance the timing of the different things, you just have some of the threads sleep for a while. One of the threads can sleep for a while, so it's not getting ahead of itself. So remember we discussed that strategy a while ago.
It would be nice to have an infrastructure for managing threads. I mean, simply for viewing threads.
Yeah.
And maybe bumping up how often each one runs.
So we don't have a general
We don't have
infrastructure for that, right? So, but that's just done for these particular agents now. But yeah, it would be
The
good.
sleeps are hard coded, right?
Yeah.
And there's no knob that you can turn and say, oh, this one should sleep less.
No.
What I'm saying is it would be nice to have that kind of an infrastructure in
Yeah.
general.
Sure.
It's not urgent.
No. Yeah, because here it's more like you can set, I want atoms in the attentional focus to have their importance updated X times per second or something. And then if it's happened too often, then one just sleeps. So you would adjust that by setting that parameter, like how often per second
Yeah,
or
but
something.
there's no way to change X.
Well, there is a way to, yeah.
We have runtime, right? We do some config file and we can see.
Yeah.
So it's pulled out of the config file.
Yeah. So yeah, that would be good to have some sort of OpenCog process manager that lets you set. In
Well,
essence,
we need to kill the config file because there's still data being stored.
Yeah.
It's the code sheet.
mhm. So yeah, I think what Lena suggested would be a next step in the infrastructure. So now ECAN is implemented, so it would take advantage of that because each of these things is in a different.
Yeah,
thread.
I'm sort of stealing the conversation. I mean, we had the conversation a few days ago about what it takes to have a version of the atom space that is production ready. And you have to deal with all these things like threads, scheduling and viewing, and it's totally boring. There's no science in it. It doesn't advance the research. It contributes nothing to what you want to do, but it's something that
Well, it
if
does
you want, if
yeah.
you want other users and other companies to adopt OpenCog, we need to have these low-level tools available.
Makes sense. Yeah. I mean, there was a lot of work in sort of reorganizing the math and the formulas in ECAN so as not to be tied to the cognitive cycle, actually, which is, it was sort of written before, like certain things happened in each cycle, things happen in a certain order. So just rearranging everything ECAN does to run in separate threads where the parameters of how often things happen are determined by clock time instead of an arbitrary notions of cycle. So
there really are no dependencies between those things where there's a rational order in which they need to occur.
No, the parameters are just each one has to have an X times per second. So that we just use clock time to coordinate between them.
It was okay to leave it as cycles, and you just didn't want to.
Yeah, but we had to change things anyway, so there were various confusing things there. And it wasn't okay for reasons I'll come to, because the way it was written would never work for a large atom space. I mean, the way the previous code that Joe wrote was, I mean, it was nice as a prototype, but what the previous ECAN code did is it built a sparse matrix which was a mirror of the atom space, and then it did some matrix multiplication on that smart matrix. So it built a whole matrix of the atom space and did some linear algebra on it, then put the results back into the atom space. So because that's how the math of ECAN was in the papers that Matt Clay and I wrote, which is fine because that's how we wanted to analyze it. But to implement it that way for a big atom space was not good. So part of the objective was just to re-implement it. So it was just doing everything on the atom space instead of building a big
I saw the
matrix.
sparse matrix, and I always wondered about that.
Yeah. Well, now it's gone. But since we had to get rid of that sparse matrix and then revise a lot of the math accordingly, we figured we would just refactor it like this. So that was okay. I mean, that's done now. The next question.
Yeah, I guess maybe it's just so the STI and LTI, are those just attributes on every atom, or
Yeah.
is there sort of separate index for
There are attributes on every atom.
But that is planned to change in some indefinite future when.
Yeah, there is a design called proto-atoms. And so we've had right now every atom has a truth value and an attention value. And the truth value has a few components, like its strength and the confidence. And the attention value has STI and LTI. And it has served okay, but we persistently come up with a desire to attach more numbers to various types of atoms. And you can do that within the atom space by creating a number node. But then that's sort of
a truth value and attention value on it also.
That's sort of, that becomes sort of bloated. So what we want to do is make a lighter weight way to attach properties to atoms. And the idea Linus had, which I think was a good one, is it's nice if, in a sense, properties are atoms, because we have ways to save and load atoms and so forth. On the other hand, you don't want properties to be that big. So we came up with the idea of a proto-atom, which is like a stripped down atom, which isn't indexed in that many ways and doesn't have that much meat to it. Yeah, so.
The new API will be backwards compatible with the old one, so it's not something to.
So once we implement that, then the proto-atom, an atom will be able to have some proto-atoms sort of hanging off it, which could represent truth value, attention value, or time, or entropy, whatever you want to associate with that atom. Then the only way to get to those proto-atoms will be from its parent atom. They will be indexed centrally, so which will be lighter weight. But no one has found time to implement proto-atom fully yet.
It's 2/3 done, and there were some design decisions that.
Yeah, we should. You and me and Mel should discuss. You wrote that down online. I haven't reviewed it for a while. It's a really good
GitHub
one.
reports.
Yeah. So, one concept which is important in ECAN is what's called the attentional focus, and that's part of a model of what you call working memory in OpenCog. So, what happens is some of the top short-term importance atoms are considered to be in the attentional focus. And then those are handled a bit differently than everything else in the atom space. And that's a bit crude, but it seems useful for various reasons, because you would like to be able to process more intensively a smaller set of things, and then everything else there, you can be a bit more lax about how often you update them and how you process them. So that's a vague model of how in the human brain you have working memory, which is treated differently than long-term memory, although it's much simpler. Now, some cognitive architectures, you have a separate working memory container, separate from the long-term memory container. Here they're all atoms in the atom space, but you just take the most important ones and you treat them differently, which kind of amounts to the same thing. So there's a number called the attentional focus boundary, and everything with an importance higher than that is considered in the attentional focus boundary. Now, what we have in the current code is just a number, so like the top 50 or top 100 atoms or something are considered the attentional focus. Now, the design that we discuss and intend to move to is there's a sort of range, like the attentional focus must have from 0 to 200 atoms, or from 30 to 70 atoms or something, and then within that range the boundary could be set based on where it seems to be a natural cutoff from the importance distribution. Because if you have 10,000 atoms in the attentional focus, then things probably aren't going to work well the way it's set up now. But having it be an exact constant is also sort of a hack. So in the attentional focus, basically there's a process that does updating of importance and spreading within the attentional focus, and it just loops through everything in the attentional focus because it's small. So you can just iterate through and update everything there. And one change that we discussed but didn't implement is for spreading to happen out of the attentional focus. You could do it so when an atom's in the attentional focus and it spreads activation, you could make the activation spread a couple links away into the long-term memory out of the attentional focus. So that's what some psychologists, like William James, referred to the fringes of consciousness. Like you have your consciousness and you have your unconscious. Then there's the fringe, like the things in the back of your mind that you know are hovering there, but you aren't quite aware of. So those would be the things, say 1 or 2 links away from the attentional focus. And you could have spreading, when the attentional focus is looped through, you could have the spreading go a bit into the long-term memory, and that helps the process of things in the long-term memory getting pulled up into the attentional focus. And then there's another parameter of how far you spread in. But we were thinking about that in the context of if the words and concepts in the sentence you just heard, they're stimulated a lot, so those are in the attentional focus. Then what you want is words and concepts related to that to soon pop up into the attentional focus. But what happens is if you spread activation, so you have this sentence like Bob bought a cat, right? So then the word cat is in the attentional focus, so that spreads some activity into the unconscious mind. So maybe it sends it to dog, which is somehow related to cat, right?
And I could send it to child
yeah.
or something like just
Right.
it's your path trajectory, your neighbor or
So
something.
Korean
yeah.
food, right? Yeah.
Yeah.
So if you spread from the operational problem that we're having is if you spread from the attentional focus from cat to dog, so dog gets some importance, but then if dog is not in the attentional focus, it might be a while until dog gets visited to be updated, because the things out of the attentional focus get updated less frequently. But if you have cat spread to dog and just have the attentional focus as spreading process spread all the way from dog to Korean food, then you're doing a little more. But that sort of thing is going to require some tuning, and we haven't really experimented with it yet. And I think this will be quite interesting in the conversation context, because it's sort of which things on the fringe of the current dialogue are popping up into mind. Yeah, I mean, this is like spreading activation, as you know, that's been studied in cognitive psychology for a long time. So this bit of OpenCog is supposed to be sort of human-like. Now, in the rest of the atom space, which is not the attentional focus, in essence, it's not viable on the current hardware and software to just cycle through all of them. Like if there's 10 million atoms in the back of the system's mind, looping through them all, it takes too long before you get back to the first one. Now, in theory, if you had a GPU that was connected really fast to the CPU, you could like update all these in parallel, because neural networks are good for that. But then doing that in a way that doesn't get bogged down in GPU-CPU communication is very hard also. So for now, what Mizgana implemented is updating and spreading in the rest of the atom space using stochastic selection. So you basically the process there grabs an atom at random out of the rest of the atom space with a probability proportional to its importance and updates it. So the things in the attentional focus get looped through, the things in the back of the mind get updated randomly. And then there's a bit of complexity, because the things are getting updated at different frequencies, right? So if you're decaying the importance of an atom, but you only visit it every minute, then how much do you decay? You have to do a correction, because so you have to do the whole minute worth of decay at the time that you grabbed it to update it. So that was just implemented quite recently, I guess. And this is the pain in the ass of implementing what's in essence a parallel process on a big neural network using a serial machine where you have a lot of RAM and not that many processors. But and again, this has to be tuned to work well on our various applications, because so there's a bit of complexity there, because you also don't want to store in each atom knowledge of the last time it was updated. So you have bins for the atoms for what their importance is, and within each important bin you keep track of how often the atoms in that importance bin are being visited. And then you use that to sort of augment or discount the amount of decay and spreading you do when it's visited, which is, I mean, it's kind of simple math of the type you often have in neural networks. Right? But the thing is, the previous ECAN version just didn't do this. It just made a matrix of the whole atom space and tried to update everything, which just took an unacceptable amount of time if the atom space was not very small. So something we haven't experimented with much yet, but which is interesting, is, I mean, if you're forming HebbianLinks, so the way that works is when two atoms are in the attentional focus at the same time, you either form a Hebbian link between them or you increment the weight of the Hebbian link between them. Now, if there's an atom in the attentional focus and it has a Hebbian link to another atom that is not in the attentional focus, then you would decrement the weight of that Hebbian link. So, in essence, the weight of the Hebbian link reflects the probability that if one of them is important, the other one's also going to be important. And you could build those symmetrically or asymmetrically. Symmetrically means if either
It's sort
one.
of like a cache to just correlate things that are otherwise would be far apart.
Yeah, right. So, now, that's much like a Hopfield network in normal neural network theory. So what you can get with these things in general is you get a sort of memory attractor. So you can have a bunch of nodes and links connected by Hebbian links. Then if you have 7 nodes and links all sort of cross-connected by Hebbian links, if 3 of them become important, then importance will spread along those Hebbian links and the other ones will become important. So it's like if cat, dog, rabbit, cat food, leash, if all these have Hebbian links among each other, then a couple of them become important, then the odds are high that all the rest will become important, all else equal. And this is a sort of distributed or global sort of memory, which is different than the idea of storing memory just in one node. So I mean, we have localized memory in OpenCog where like there's a cat node, so that's concept node for cat, maybe linked to the word node for cat, then links to the other things related to cats, and that's a sort of explicit symbolic memory. But to the extent that knowledge is stored in sort of complexes of nodes linked by Hebbian links, then you would have a Hopfield net-style distributed memory. And of course, the two could work together because the nodes connected by these Hebbian links include.
Well, no, I mean, if there's something specific about a cat, some bit of knowledge, you wouldn't use a Hebbian link to encode that.
No,
The Hebbian
but
link is just there to help with the attention.
kind
with what
kind
you're thinking
of.
about at the moment.
Well, but if there's a bunch of things that happen to be, it's like a network of nodes read by Hebbian links could constitute a concept in the process of formation. So
the process.
if you have a bunch of people and concepts and objects that seem to occur together a lot, but you don't quite know why yet, those are going to be connected by Hebbian links, and when you think about some of them, some of the others will pop into mind. And then it's up to some other thinking process to figure out
Well, I mean,
why are these things all important at the same time.
So if you haven't figured out that dogs and cats both have 4 legs, this is somehow, okay, so somehow you have this Hebbian link that gets created between having 4 legs and being a mammal.
Yeah, because, well,
But
take,
at some point you have to convert that to
yeah,
something other than Hebbian,
yeah,
because you'll forget it otherwise.
sure. Yeah, say that
No,
cat, say that,
relation is.
yeah, if Linus and trouble often occur in the attentional focus at the same time,
I mean,
then,
I could just stay silent.
no. All right, we'll pick a different. If Eddie and trouble often occur in the attentional focus at the same time, the system may not know why, but then building that Hebbian link there will cause you to think of trouble when you think of Eddie and vice versa. But then having both Eddie and trouble in the attentional focus, the idea is that would cause reasoning and other processes to think about them both together, which would cause the reason for that co-occurrence to be discovered. Then you would realize, well, okay, it's Eddie causes trouble, or it's like Eddie has a dog that follows him around and causes trouble, or whatever the logical reason is. So to discover the logical reason for that connection, some cognitive process has to think about those two together. And if the cognitive processes tend to grab things in the attentional focus to think about, then the Hebbian link between them will cause those two things to be thought about at the same time. And we had some,
Yeah, I'm sorry Nil isn't here, but I'm thinking we need
Yeah.
to have sort of a worked example of that.
So we haven't-
Starting not knowing something and walking through it until you
Yeah.
lose that indeed the reason Eddie has trouble is he's got wheels or something like that. Oh, on wheels, right?
yeah. So the closest thing to an example of this we have, which isn't quite there, is the paper that Matt Eclay and Miskana and I published last year. So that used a toy reasoning example from the Markov logic network literature. But what we were doing there is we had PLN logical inference and ECAN working together. So the PLN inference engine chose premises for its logical inferences by what was in the attentional focus. So it chose the important things as premises. Then when PLN derived a surprising conclusion by a simple entropy formula, then the short-term importance of the conclusion was set higher if it was a surprising conclusion. So then the surprising conclusions, the atoms involved in that, in the surprising conclusion will get chosen preferentially by PLN the next time around.
Okay, you need to create some link. In the end, don't you want to create some more permanent link?
Well, PLN is doing it, right? I mean, PLN, when it does reasoning, it's creating inheritance links and evaluation links.
So it'll just be inheritance links, okay?
It's inheritance and evaluation links, but the point is PLN has to choose what premises, right?
Yeah.
So it chooses the premises based on importance. Then when it gets an interesting conclusion, it gives that interesting conclusion importance, which then spreads. So the premises it chooses are things that were associated with its previous interesting conclusions.
That somehow stored to long-term memory.
It's all, everything's in, I mean, it's all the atom space. So the atom space by default is long-term memory. And then the percentage of the atom space with the highest short-term importance is called the attentional focus. But the thing is, this example was a little toy example. It's like there's a bunch of people who smoke, a bunch of people who are friends with each other, then a bunch of people with cancer, and you wanted to infer that people who are friends with people who smoke have a higher odds of getting cancer than people who don't have any smoking friends, but lower than the smokers, right? So it's a very sort of, it was a trivial toy reasoning example that came from Markov logic network literature. So we were just showing that by putting PLN and ECAN together, you could get the system to do the same stupid inferences that Markov logic networks do. And if you just do PLN without ECAN, then it takes forever because it's just searching the whole atom space for its premises instead of having any way to bias what premises it should choose. But that's a sort of,
Had her hand up.
No, it's cool, it's like I'm answering.
All right. So, yeah, that was his paper on PLN and ECAN synergy. All right. So, the last thing that came up a couple days ago in conversation was we were thinking about how to use this mechanism in our Hanson Robotics chatbot work. And that's, in a way, that would be a simpler use of ECAN than like associative memory formation or something. But it could start off simple and then grow into something more interesting. So the idea here, which came out of a conversation with Manhin and others in the office, is to use ECAN to choose the rules to apply to the current sentence. For example, rules that were either imported from ChatScript into OpenCog, or sort of ChatScript-like rules that were written in OpenCog. So in ChatScript, the rules are organized into topics. Each topic has some key phrases associated with it. Then each rule is basically sort of Eliza-like if then rule. Like if you said, "Hi, how are you doing?" Say, "Hey, I'm great." Or if you say, I live in China, you say, "Well, how do you like China?" So you have these hand-coded if-then rules, which can have various variables and fuzzy matching markup and so forth. So they're a bit fancy. But you have a bunch of if-then rules associated with some key phrases and organized into a topic. And part of what makes ChatScript often work less annoyingly than AIML is that the topic-based organization is used to constrain the matching. So in AIML, a lot of the time you're ending up matching a large amount of rules against less sentence that came in. In ChatScript, generically it works more like you see what key phrases have occurred recently. That positions you in a certain topic. Then you match the rules inside that topic. And then there's a layer of heuristics for topic management. So like in some topics, once you've been in that topic, you may stay in that topic a little while. Or there may be a rule saying after you've been in this topic, you want to switch to a specific different topic after that. And there's ways to configure that. So that tends to give more semblance of coherence to the conversation. So AIML conversation, unless the rule base is crafted really precisely, just tends to be like a series of one-liners. Like, you said this, the robot said that, you said this, the robot said that. Whereas a ChatScript conversation tends to be more like a series of little chunks of 3 or 4 things, and it hops around among those. So it still doesn't solve, so far as I've seen, like overall discourse management in terms of having a whole conversation that has some meaningful arc. But at least it's better than just a series of one-liners anyway. And those mechanisms all exist in AIML in a sense, but they're extremely annoying to use. So one of the goals we were discussing was how to make OpenCog do ChatScript-like dialogue management.
Well, this is, you just hit on something key. It's like all those mechanisms exist in AML, but they're annoying to use, right?
Yeah.
So the conversation I had the other night was, it's like all these other mechanisms that we talk about, if they're annoying to use, nobody's going to use them.
Yeah.
So this is, it's kind of a side note, but if the
Yeah.
mechanism you're describing on this page is,
It's more than annoying
Well, this,
to do.
what I'm describing in the back on this page is
well,
really
it's there. I mean,
this
it's
is-
computationally complete. You can always accomplish that.
Emo is never going to be as complete as JavaScript.
Yeah, it's
It's
not.
annoying to use.
well.
No, it's more, it's annoying and it's time consuming and it's like, it's not.
Those are all synonyms for annoying.
It's like using XML to do C++. It's just not, because the
I mean, the mechanism is there, it's just.
It's just an awful
Wasn't
mechanism,
used.
yes.
Yeah. I mean, it is Turing complete, so, I mean, you could implement a
Theoretically.
thinking machine or Microsoft Word in AIML. And Kino came close, which is interesting. Like, Kino made this
Oh, he did, didn't he?
astounding AIML system where he used AIML like a kind of neural network. So he has AIML rules that have no words that are understandable by humans, but he has like a rule whose input is text, whose output is some symbolic tokens. And another AIML rule mapping symbolic tokens and variables into other ones. So he has this whole connected neural, not just feed forward, and recurrent neural net where the firing is all AIML rules. So, which is, it's amazing in a sense, but nobody but him will ever want to understand it. It's slow too. But
I would say, like, if I had to concisely describe where the big fail is, given that, you know, these topics are sort of in there, topic,
yeah,
that its matching order prioritizes literal matches at the beginning of the string higher than, you know, keyword matches with a key thing that you want to match. So if you say, here's a topic, and I would like to match this kind of keyword when that topic is active, that's the basic thing that you want to do, but this other rule sort of says, no, something else will win, that
Yeah.
the first two words. So the only thing that you can ever do to get phrases within a topic is to match any phrase.
yeah.
And then, like, if a person tries to change the subject or says anything slightly off, then you fail to get your
Yeah, I mean, I remember when I was writing AIML rules to match one thing conceptually, I wrote like 50 rules with wildcards distributed in various random positions.
And you didn't try to use topics because, you know, I mean, like, so Bruce Wilcox.
I did
suggests
use
that
topics.
says
Yeah.
The topics are useless, and I would say they're kind of useless in AI.
It's
Well, I mean, I didn't want to turn this into an AML and chat script there. The general idea was that if we build something that's hard and annoying to use, nobody will use it.
but this what I'm
So
describing,
we run that risk.
what I'm about
Yeah.
to describe here,
Yeah,
what I'm discussing here is purely in the back end.
But yes, this is.
Right? I mean, I think that is a point. Is if we want to make a dialogue authoring framework in the Scheme shell or wherever for people to use, it has to be easy to use. That's true.
it's true, because we'll use whatever is the easiest thing. It's lazy like that.
Well, all right.
Well, no, that spreadsheet was the easiest thing, and that's not what we're using. So there is also
Not sophisticated
Yeah,
enough.
well, then there's the balance.
So no, but that's the
Yeah.
problem, is it turned out
Yeah.
to not be easy for what we wanted to do because it's not
Yeah, yeah.
sophisticated enough.
Yeah,
So
yeah, sure.
therefore,
Well, I
not
kept saying,
easy.
make it more sophisticated.
We did. We had a spreadsheet with 50 columns. Then it was
Well, I
impossible.
kept saying
to
it's
You
not.
can't
Then it
see
was
it.
impossible to
Columns.
understand. Yeah. So,
Not
yeah,
easy
yeah.
again.
so there is a balance between being easy to use and actually
Getting the shit
doing
done.
enough things that you need done. And yeah, I think we can make something in OpenCog scheme shell which is of the same level of ease of use as ChatScript. And because ChatScript in the end it's not astoundingly easy to use anyway. So I think at first the goal given to us by David Hansen was to make something for encoding dialogue and movement content in OpenCog that could be used by writers and artists with no technical background. And I didn't really see how to do that. So then at some point the bar was changed and it was, okay, make something that's roughly as easy to use as ChatScript. And I think we do see how to do that, because ChatScript honestly isn't easy enough to use, and I could take someone with a pure non-technical background and they could use it effectively, because it's an easy programming language, but it's still a programming language.
That's me, but you know, and
Yeah.
I have no technical background, but it is a programming language that I can apprehend because
Yeah.
it's super logical.
There's
And
different levels of complexity.
yeah, it's like
Yeah.
it is possible for me to get
Uh-huh.
in there, but there's a learning curve. You know,
Yeah.
it's not like the first day, but
I see.
You
Yeah.
get the team to help each other.
And
Right.
but the examples are really good. So it's like the manual is like, it's like a climbing this, it's like possible, you know?
That will be the biggest challenge, is
Well, we'll
that
see.
ChatScript has nice documentation, right? And that, I think we can make a syntax which is as easier than the ChatScript syntax, but then producing the documentation for it will take some time. But what I was going to go over here briefly is just in the back end, I think one can use HebbianLinks and activation spreading to implement the rule selection, which is sort of independent of how the rules are authored. So the idea would be if it wouldn't have to be like that. It would be more like you have nodes for the keywords and phrases, and we have ways to represent that in OpenCog. And the keywords and phrases will be linked to a node for the topic. Then the node for the topic will be linked to the nodes for the if-then rules. So what happens is if a keyword or phrase is recognized, that spreads some activation to the topic. If more of them are identified, that would spread more activation to the topic. And you could also give weights to these links if you wanted to. So some keywords or phrases get more oomph to the topic than others. And I mean, you could also have negated words or phrases if you had a way to do it. Like if this thing is mentioned, then you're probably not in that topic, right? Then from the topic node, you would have links to those rules. So then activation would spread to those rules, and then that would give these rules more oomph if these key words and phrases had been there. And then the process that applies rules to a sentence would basically take, well, what were the rules with the most importance now, and it would apply those. So if you were in the simplest case, you could have, for example, inhibitory Hebbian links between different topics. So if topic 1 and topic 2 there were inverse Hebbian links in the system. So if topic 1 and 2 had an inverse Hebbian link, then when topic 1 was active, topic 2 would not be active. And so then that would enforce a quite ChatScript-like control mechanism where you're in one topic at a time and just using those rules. But the nice thing about this sort of framework is that because of the other things the admin space says, there's more flexible things you could do also.
Okay, so with the inhibitory Hebbian link, is this a thing that's like hard-coded? Like, if you're thinking about X, you cannot think about A, or is it more like generally coded, like you can only be in one topic at a time?
You could do it any way you wanted to.
I'm just trying to understand what an inhibitory link is.
Inhibitory link, in general, an inhibitory link just means if this node is active or important, then when it spreads importance to this other node, it will decrease the importance of that other node.
So, okay.
So that's the general notion of an inhibitory link in a neural network, right?
So if I really want candy, like I won't think about my diet like that, you know, like, I don't know.
The point here is if you want the system to only be in one topic at a time,
Right. Yeah.
then you can take the nodes for the topics and you can make inhibitory links between them so that when one is important, the others become less important.
Okay.
And then the dynamic that will lead to is one is important and the others are not. Now, that's kind of ChatScript-like. I don't think it's always what you want, actually. I mean, in general, I want a system to be able to have more than one topic on its mind at a time. And then that just depends how are you linking between the topic nodes. So I think one exercise is to implement a fairly closely ChatScript-like control system using this machinery. And then another exercise, which is more interesting, is slip further away from being exactly ChatScript-like and have more flexibility there. And then, of course, that brings you back to the authoring challenge Linus mentioned, because the more flexibility you have, the more complex things can be. So, I mean, if we make this,
You have to provide authoring at a different level.
right, so if we have a sort of domain-specific language inside the OpenCog Steam shell, then there can be very simple authoring language that's like the subset of ChatScript you guys are now using that lets you do certain things. But if you want to do something fancier, you can always write Steam.
Well, the thing Content and I were talking about is in the end you want to have a relationship similar to that between a director and an actor, where the actor knows how to do things and the director just says, do these things, but the actor more or less autonomously is able to accomplish those things without having to be very highly detailed about them. So you have to provide that high-level interface.
Yeah, and the directors have a lot of different styles in terms of how much detail they want to give actors too. So
Right, so
Well,
we
here
could
we're-
have a better, we could use it simply an example of like, if, I'm like a, if I'm the director of maintenance and I have a plumber that I need to send to repair
Yeah,
a
sure.
sink, I don't have to explain,
Well, right,
this is
and-
how you repair a sink.
And this
They
is
know.
all definitely plumbing here, right?
Yeah.
Yeah. Yeah, so there's more complexity to the chat script execution than what I just described here. Like the rules are given in a certain order, and one rule wants to be applied before the other one, and then you want a rule not to be repeated within a given session. And those can all be implemented in this sort of framework if you want to. And I guess my hope is that by doing it that way, we get something that we can play with in other various more interesting ways afterwards. Because similarly with the keywords and phrases, like in OpenCog, you could interpret those, you could do synonym matching on those or not, right? And if we have a Chinese interface to OpenCog, which Huawei wants us to build next year, then you could have this synonym to that word in some other language in there.
Nice.
And if someone says that, then it could stimulate that anyway, right? So I mean, you get more flexibility by having things in this semantic network, although it's a little more complicated to build initially. I mean, we couldn't have done this 6 months ago because ECAN didn't work except on very small atom spaces, and now it appears to function. Does it work?
We need to play with the parameters.
You were saying something.
Yeah. So before we really switched into chat script direction, I've been thinking about doing this thing where I wanted to say, can I take key phrases and do something like a semantic distance to content that we had in our answer store or something, using something like word to back distance. So like I read in a big corpus and I can just say like, okay, what have I got that's, I don't have anything to say that matches this phrase, but do I have anything to say about semantically close things? So now, I guess with this kind of thing, what I'm thinking we might be able to do is just say we've got a lot of things that we can talk about, which are, sort of answers that we've loaded in, or some kind of ontology that we've ingested, or just interesting things to talk about. And so then, what if we maybe, as a batch process, we run something like a word to back thing over all of the conceptual nodes, the nouns, that kind of thing, and build in HebbianLinks based on that distance, right? As a kind of initialization to say like, this is sort of like we build the topic barriers without having to actually code them.
Certainly can do that. Yeah. I mean, I think word to vec in particular. Have you played with it much?
Not much.
So what we found before is the pre-trained word to vec models are nice. When we tried to train our own, they were very crappy. So I think they trained their pre-trained models on an insanely huge corpus.
Yeah,
Which would
so
be-
some kind of newspaper corpus
when we tried it on simple English Wikipedia, it was kind of crap. So the pre-trained vectors, you can take their dot product and see how similar things are, and that's easy to do. To train new word-to-vec models, someone would have to take time to get a very large corpus and do the training. That's not impossible to do. Right? But the quality of the model was worse than I thought it would be based on simple English Wikipedia, which was not that small a corpus. You remember that, man?
It's a category because vectors and
Or
syntax
just part
are
of it,
both.
yeah. What's that? It's crap.
No, it's this you keep saying, like, well, where's the category theory? And category theory makes it very clear why word-to-vec is what it is, right? Vectors and syntax are both monoids, and the vectors just may force a symmetry on there that isn't naturally there in the syntax. So yeah, it kind of works, but you're clobbering some of the most interesting things about syntax, which is the fact that it's not symmetric.
Yeah.
So
No, I mean
so
it
this
is
natural explanation. Here's why it works, and here's exactly where it's.
it is nicer to calculate similarity based on the output of syntax parsing and semantic interpretation.
Yeah, it gives you a sort of a very clear picture of where to go.
Advantage
It's the
of
part
word-to-vec
the vector that you
is
have to untangle.
training it is kind of fast, so you can take like all of
Well, you
Wikipedia or half the web or something
can
and just train it.
train on the graphical model just as well. Just keep the non-symmetric parts of it. Don't force symmetry onto it. The algorithm doesn't have to change. Just use the same algorithm, but do it in graphs instead of vectors.
How do you produce those graphs? You have to parse the
Produce
sense.
vectors, right? It's the same monoidal category.
Well,
It's exactly the same monoidal category. Just translate it. Just don't force the symmetric. Remove the symmetric constraint.
word-to-vec is
Well, you have
based.
to understand what I'm saying before you can do it, right? You have to understand why a vector is a symmetric monoidal category.
I understand that.
Why it inhabits that. Well, if you understand that, then you know which constraint it is that one removes.
I don't know, because word-to-vec, I mean, they take co-occurrence vectors and it's a dimension reduction, right? So they're doing neural network.
You can do dimension reduction, just don't store it as a vector.
Well, what they're doing in word-to-vec is they take the sparse co-occurrence vectors associated with words, and they use a recurrent neural
Once you
net.
say the word vector, you've already symmetrized. It's already too late by the time you say the word vector.
Yeah,
You've already lost it out.
right, but what structures do you want to apply the dimension reduction to? I mean, the parse trees?
I can't do it off the top of my head. I mean, you have to sit down and look at what the actual relationships are that are being clobbered and untangle those and go back through the parse trees and say, oh, here's.
Yeah, but they don't parse at all in word-to-vec. I mean, they really just take co-occurrence vectors and dimensionally reduce
Yeah,
them.
you're trying to take a complicated problem and solve it live in front of an audience. I'm not going to do it, you're not going to do it.
No, my point was just that if you're parsing, then it's much slower than what they're doing. So what they're doing is stupid.
I didn't say parsing, you're the one who said parsing.
No, I didn't understand what kind of graph you want to build with. So.
The monoidal category, the internal language of the monoidal category that removes the symmetry constraint that is attached to symmetric monoidal categories. You have a left inverse and you have a right inverse. Store the left and right inverses separately. Don't take the average of the two. It's the average of the two. You take the average of the two to get the vector. Don't just keep left and right separate.
I'm not sure asymmetry is enough to give you an interesting structure. I mean, you could just
It's
take.
the only difference between syntax and vectors. It's the only difference between syntax and vectors.
Well, no, because you could just take co-occurrences that occur after a word versus co-occurrences that occur before a word. But you're still,
No,
you're,
that's not what I'm saying.
that's asymmetric, but it's not interesting.
That's not what I'm saying, though. Yeah, I mean, you'd have to understand what you'd have to study this stuff for a while, right? It's not just gonna pop into your head like magically. Oh,
I did
I'm
study-
sorry. I mean, we should take this offline.
Sure.
There is a way to. What I'm trying to say is, there's a way to do this. I cannot do this at the blackboard.
Sure.
It is known.
I did study that
The
stuff.
word to
a couple
vec
months
guys
ago.
don't know it, but one could do this. It's not. I mean, it's known to other people. It's been published. The machine learning guys have ignored it and are intentionally remaining.
I looked at the papers that you're referencing a couple months ago somewhat carefully, and these guys were trying to. It's also a bit silly in a way, but they're
Which papers am I trying to?
well, there were these were talking about quantum theory in language, right? So they were mapping.
Quantum is
They were
semantic,
mapping.
yeah.
These papers were saying. Actually, these guys were saying semantics is vectors, and syntax is these asymmetric categories, and they were looking at mappings from the one to the other. So they were
Vectors, yeah.
but they were representing semantics as vectors and syntax as the asymmetric category, and they were looking at mappings from one into the other.
Sure, well, you've moved,
Yeah, but
you've moved the vector part to a different location.
hmm,
But
but yeah,
well, it's interesting. It just says the vectors are an interesting way of storing, I don't know, semantic
Yeah, yeah.
information, whatever you want to call it. But there's also a reason why they're imperfect and why these methods don't.
well, so right.
Saying the memorial category is
Right
is
now-
the key for that left finger snare opening that lock.
Right now, if we just wanted to have sort of fuzzy synonymy between words, the trained word to vec models do that better than like WordNet similarity or something, and not as good as many other things that we don't have and don't exist yet. Right? So, I mean, if you want to plug something in at this moment, you can call the trained
Yes,
WordNet
at this
model,
moment,
right?
use
So-
word to vec.
If there's a smarter way to do it without parsing, I don't know what it is at the moment
No,
either.
I have to explain.
But that's a good discussion to have later.
Yeah, well,
All right. Well, that is ECAN. Any more questions, comments, insults?
So at this point,
Just joined rambling? Yeah.
I guess in principle, when we have something like psi in the emotion driven, let's say a rule is fired, a goal, a drive is active, then at some point in time it would make sense to be putting that into the ECAN and upping the short-term importance.
Yeah, definitely.
But
Whatever is of high emotional,
How far are we from being able to do that or wanting to do it? Or
couple of days, I don't know. I mean, you can boost the importance of what has high emotional valence, right?
yeah,
I mean-
it's just attaching.
I think that the challenge there, and that's actually the next topic for today, but the challenge there is having a meaningful emotional reaction to anything, given the lack of sensory input and lack of understanding of the world, right? Like, you can take a positive or negative valence word and say, okay, we'll boost emotional value of that, and therefore everything related to that is important. Or you can say, I saw a familiar person who said nice things, so I'm happy. So that's important. But
Before beauty.
there's not that much emotional content to the system's experience. But
Right.
once you have that emotional evaluation, it's easy enough to boost the importance of that and let the importance spread. Howdy. Hey. Yeah.
So Ben is our chief scientist, and he's giving a lecture on artificial intelligence, the AI software development.
How you doing, Doug?
Good to see the team.
Yeah.
And, so
Actually, we're maybe done with this segment. So let's take a 5 or 10 minute break, and then we will resume. And actually, the next topic was emotion and emotion-driven action selection and stuff.